Now let's say you want to find x values from a probability, which means you're going to start in the middle of the table and work backwards. This is truly like trying to find the closest value. So it says, given IQ is normalized with a mean of 100 and a standard deviation of 15. That's the population mu is 100, standard deviation sigma is 15. Find the IQ scores for the lower 90%. So I'm going to find the cutoff for the lower 90%. Okay, well, first of all, is that a positive or negative z-score? Let's think about that. Draw a visual. Remember, down the middle is the 50% mark. So the lower 90% would be somewhere over here, but 90 is not there. 90 is right here. It's in the middle. So you have to find the closest answer to 0.9000 and go outwards to find the z-score. You have to start in the middle of the table. And even if you didn't know if it was positive or negative, you'd have to search both pages, but at least now you're only looking at one page. So we're looking at 0.9000, positive z-table. So somewhere in the middle here, somewhere we're gonna find you. Where are you? It takes a minute with some practice, and that's the closest answer right there, 0.8997. That is the closest to 0.9000. It's closer than that one. That one's only 10 thousandths away. I was trying to think of the decimal places versus 15, 10 thousandths away. So that's a z-score of 1.28. You're supposed to get the closest value, 1.28. Here we go. So z-score is 1.28. And that'd be great if that's all you needed, but that's just the z-score. Now we got to find out what was the original IQ score cutoff here. So remember, z equals x minus mu over sigma. 1.28 equals x minus 100 divided by 15. Two steps. Multiply the 15 up, add the 100 over. Again, multiply the 15 up, add the 100, and you'll get a cutoff input value of 119.2. So that's for the lower 90%. What if it asks for the upper 30%? Well, remember, your table only reads the lower percentages. So the upper 30 is the same thing as finding the lower 70. So once again, you're going to go ahead and find the lower 70.7000 to find out what that z-score is. That's, again, a positive z-score because I'm over the 50% mark. So 0.7000. Let's see what we find here. 0.7000. Which one's closer? Which one's it? Looks like it's that one. Okay. 0.6985. That's 15 away. That's 19 away. Yep, that's it. So 0.52. 0.52 is the z-score. I'm 0.52 standard deviations above the mean. My z-score is 0.52. So here we go. So 0.52 is equal to x minus 100 divided by 15. 0.52 times 15 plus 100 will give me a z-score of, not a z-score, an input value, an x value of 107.8. And then lastly, the middle 60%. Well, the middle 60%, that's two values, which means I'm going to find two z-scores, but I need the two probabilities. 60% in the middle means I've got 40% left over, or 20% on each side. So that means I have to find the lower 20% z-score cutoff and the upper 20, but the upper 20 is, if you notice, 60 plus 20 is the lower 80. So I have to look up 0.2000 to get that closest z-score and 0.8000. So let's do this. Negative z-score time, 0.2000. Let's see what we can find. And this does take a minute, okay? Shouldn't be quick. I mean, the more you do it, the faster, I hope. Okay, 0.2000. Where are you? 0.2, not over here. Those are 0.2. There we go. Negative 0.84. Again, negative 0.84. Let's go to the positive z-score for 0.8000 for that probability. 0.8000. Where are you? Oh, there we go. 0.84. So if you notice, the middle 60%, the z-score above and below is the same, just the opposite sign, which should be expected because from the middle, it's the same above and below, kind of like the whole 68, 95, 99.7 rule. So from here, we have a z-score of negative 0.84 as z-score positive 0.84, we're going to do x minus 100 divided by 15, x minus 100 divided by 15, and we're going to find those two cutoffs. Negative 0.84, multiply up to 15, add the 100, do the same thing for positive 0.84, multiply by 15, add 100, and it's going to be between 87.4 and 112.6. Make sure to go back, follow this, go through the z-tables, calculate all this, and that's again when you are given a probability and asked to find the actual input original x value.